The Air Force is launching a raid on an enemy industrial site. The group captain planning the operation knows that for every ton of bombs dropped, there is a 70% chance of hitting the vital areas and disabling the industrial site. How many tons of bombs should be loaded up before the planes launch to ensure the industrial site is destroyed with at least 95% likelihood? Okay. So we know each ton of bombs gives us a chance of destroying or disabling the enemy industrial site. Okay, but we can't just launch all our planes loaded up with all the tons of bombs that we could. Yeah, we would definitely destroy the site, but that's really not an effective use of resources. So what we're going to look for is the minimum number of tons, okay, that we need to load up in order to get at least a 95% likelihood. All right. Now, what we've got here with a situation is each time we drop a ton of bombs, we either disable the site or don't. So that's two separate outcomes. Okay, this is Bernoulli trial. This is repeated experiment trial territory because we've got so many tons of bombs. If we have 5 tons of bombs, we run our experiment of disabling the enemy site 5 times. Okay, but we don't know if we're loading up 5 tons of bombs or 2 tons of bombs or 50 tons of bombs. That's actually what we're here to work out. Okay, so we're going to let n be the number of tons of bombs that we want to load up. Okay. Now what we want is the probability that the site is destroyed. So at least one of the tons of bombs disables the site. And that's what we're interested in. And we want this specifically to be greater than 0.95. We want a 95% chance of destroying the industrial site. Okay, but how do we calculate this? Okay. And moreover, where does n fit into all of this? The number of tons of bombs we load up. That's what we're after. Okay. But we need to pick n to ensure this particular probability. Well, how do you calculate at least 1 ton of bombs destroying the site? I mean, you can calculate the probability that exactly 1 ton will destroy it. Probability of 70% chance. So you load up 1 ton, you drop that 1 ton, 70% chance. So what could we do? Well, at least 1 ton of bombs doing their job is the same as not, so we'll do 1 minus, okay, no tons of bombs hitting the site. And we still want this probability, even though we've now written it a different way, to be greater than 0.95. Okay. But now we have an exact number. So of all our n tons of bombs that we drop, we want exactly 0 of them to hit. And because it's exact, we can let n be our unknown, and we can let k be 0 here in our n choose k, p to the k, 1 minus p to the n minus k formula. So that's great. Now we still have our unknown n that we're trying to solve for. We want the minimum value of n that makes this true. What's p? Okay. Well, p is the bombs successfully disabling the site. And they say in the question, 70% chance of hitting the vital areas, disabling the site. So p here is going to be 0.7. So now we have a nice inequality involving n. We can clean this up a little bit. N choose 0 is always 1. 0.7 to the 0, anything to the 0 is always 1. So we have 1 minus 0.7 is 0.3. So 0.3 to the n minus 0 is just n. So we need to find an n that makes this true. So we could subtract 0.95 from both sides, and we could add on 0.3 to the n to both sides. And simplify a little bit. So we want the minimum n, the minimum number of tons of bombs, to satisfy this equation. Well, not an equation, inequality. So we know it's got to be an integer number tons of bombs. Okay, what we can do is we can make a nice little chart here. Okay, so maybe we'll load up 1 ton, or 2 tons, or 3 tons, or 4 tons. If we need to go 5, we'll go to the next page. Okay. So in the middle, we're going to calculate this 0.3 to the n, and then we're going to ask the crucial question, is this less than 0.05? So 0.3 to the 1, well, that's just 0.3, and no, that's not less than 0.05. 0.3 squared, well, that's 0.3 times 0.3. You can work it out on the side. 3 times 3 is 9, and move the decimal place over twice. You get 0.09. That's closer, but not quite there. Okay, if we do 0.3 to the power of 3, you can actually keep going off of our 0.09 calculation. Just multiply by 0.3 again. 3 and 9 is 27. But now we have 2 and 3 numbers. So we move over the decimal place 3 times. So 0.3 cubed is 0.027. And that is less than 0.05. Okay. So at minimum, we need to load up 3 tons of bombs. Okay. If you did 0.3 to the 4, you would get 0.081, which would also be less, but we're looking for the minimum number of tons of bombs, and that way we don't cause excessive civilian damage or just waste our bombs. So our answer is going to be 3.